Hi guys, welcome to this new demo where I will be trying to explain you the principles of perspective. So what is perspective? Perspective is an illusion that affects the drawing techniques every time to try to sketch groups of objects containing parallel lines in the space. So perspective has been codified in the Renaissance in the center of Italy, in Florence, in the 15th century, and the Brunelleschi architect is the one actually that is considered responsible for having been able to codify how perspective works, and it took a lot of time. So it's very difficult to simplify it in a few words, but I will try to. But by the way, what are these slides? This is the cupola of the Duomo in Florence, and he's the one that designed it. And these are some of the drawings that are demonstrating basically the studies that he did at the time. Okay, so I would start talking a little bit of objects in the top view. So let's pretend to sketch a table in the top view. A table in the top view looks like a rectangle. These are the legs. You cannot see the legs because they are underneath, but they are there, and I just draw them. A table can be placed like that, but it can also be placed with a different angle, okay? And this is the top view. Okay, so how many groups of parallel lines can you see here? So basically this is one, but then I also noticed that these two lines here create actually another group of parallel lines, and of course also these lines belong to the first one. So one group, two group, but let's check this other table. So it's the same table, but it's tilted. It has a different angle. So let's see what happens. This is another group of parallel lines. And if I pay attention, I'm pretty sure that I noticed that this is also another group of parallel lines. So in this case, I have four groups of parallel lines in the top view. Okay? So remember, every time that you are going to sketch a product, or you want to duplicate a design in your drawings, you have to think, how does my object look like in the top view? For simple object like this, pretty much is all about two groups of parallel lines. It can be a keyboard, it can be a computer, it can be a car, it can be something very complex. But because our technology today uses the 90-degree angle a lot, all we see is basically objects that can be put into boxes, into squares, into rectangles. Two groups of parallel lines. Okay, so when I try to switch from this scenario to a three-dimensional view, so top view, now I want to switch from here to a three-dimensional view. I show you what happens. So pretty much in the space, when I try to sketch this, it's going to look like this. Okay, so a table is going to have, the legs here like this. This is going to be hidden, and the other one is going to be visible here like that. So I'm moving from top view to three-quarter view. Now let's try to see what happens to the groups of parallel lines. If you notice, the green lines are going probably to meet somewhere here. The blue lines will meet somewhere here. The red lines probably are going to meet outside the page, and the yellow lines will probably meet here. The interesting thing is that these 4 points where the group of parallel lines meet, they are laying on a single straight line. That straight line is called the horizon line, and in drawing it is indicated as HL. Okay, what is unique about the horizon line? The horizon line is drawn as a straight line, but in the reality it's not a straight line. In the reality, the horizon line is basically an arch. It's a rounded line like this, and you know why it is like that? Because it represents the end of the planet Earth. So I'm just going to add a little bit of sky to this drawing real quick, like this. So this is the space, this is the planet Earth, and because the planet Earth is so big, we usually perceive the horizon line as a straight line. But in the reality, so here I would actually see aircrafts, you know, spaceships, whatever we have. But the horizon line is basically a circle. I'm just gonna go back and we move it to the original scenario where I was basically drawing a straight line like this. Okay. So when sketching three-dimensional views, we always sketch a straight line like this. And every time I am designing objects that contain multiple groups of parallel lines, that number identifies how many groups of parallel lines we have, identifies how many vanishing points you have. You can have one, you can have two, you can have three, you can have infinite possibilities. Okay, so remember, it is not true that we only have two vanishing points. We can have 3, 4, 5, 1,200. It depends on the design that you're doing. Okay, in architecture and for product design, most of the time we only sketch two, because like I showed you, pretty much every object in the top view looks like a rectangle. If I want to speak about vertical lines, usually these are just vertical, unless you have a complex design that looks like a pyramid, but we will talk about this later on. But for now, we consider vertical lines all parallel and they don't vanish anywhere. Vertical lines are just perfectly vertical lines that don't never reach the horizon line. Okay, how many types of perspective can we use? So there are basically three possibilities. You can keep the horizon line very low, and if you notice, if I keep the horizon line very low, whatever I draw here, maybe I'm sketching a box here like that, or I sketch another, you know, object here like this. I'm just, you know, keeping it loose. I don't want to sketch something super precise. In this case, there is one vanishing point here, one vanishing point outside the page here, one vanishing point at the other side. So basically we have three vanishing points, which means three groups of parallel lines. In this case, you see that this type of perspective is good to sketch flying objects. So you keep the horizon line very low when you want to design flying objects and you want to show the bottom of the objects. Okay, remember that in the horizon line, basically you can sketch mountains here, you can sketch clouds, buildings. It's up to you. Okay, so you keep the horizon line very low when you want to show the bottom of the objects and when you want to communicate that these objects are flying. Okay, great. Another scenario is to keep the horizon line in the center of the page, and in this case this is pretty good for architecture. So every time you want to design, you know, a building, like this could be a house with some windows, maybe there is a tree here, some people. Okay, for this type of perspectives where you don't need to see the top, you don't need to see the bottom, but basically all you care is the sides. Keeping the horizon line in the middle of the page is a good, I think it's convenient, is a good idea. Do we have another scenario? Yes, we do have another scenario. We can keep the horizon line very high, and this gives us a lot of space to sketch whatever we want to design here. So if I want to design, for example, a mouse, and of course I'm just, you know, simplifying it a lot, and my line quality here is not great, but I'm just going to show you basically the idea. For product design, keeping the horizon line very high is pretty much always a good idea. It always works. Every time you need to show the top of the object and a little bit of the side, it could be a car, it could be a mouse, it could be a table, it could be a chair, it could be anything. It's good to move the horizon line as high as possible. So very common in product design. Remember, you can always sketch the horizon line, tilting it to angles. So this is always a good idea to create dramatic perspectives. Usually designers do it a lot in product design. They do it a lot for flying scenarios. For architecture, it's not so common. Okay, so practice with this, and I'll see you in the next video.